Plus, I didn't put these on, so my sound was terrible. All right, so let's reiterate that. Okay. And actually, I'm going to lasso this and destroy it and restart it. So don't even write this down yet. I want to break this down with you so you can write this along with me. So what did we just find out? Here's our little parent y equals wrong. Here is our new tan graph. We're going to throw an A. That's how we're going to start the notes. We're going to do a couple examples where we just change the amplitude and change the period. This is what you need to lock in. This is your job to really quick write this x-axis, y-axis, and get the components down. So what happened with tangent? Without a right-left shift, 0, 0 is a point. Tangent of 0 is 0. So that is a point. So the period is not 2 pi over b. The parents of both cotan and tan have a period of pi. So all baby tangents and cotangents, the period is pi over b, not 2 pi. So you got to get that in your mind. This is why we do cotan and tan last, because it's such a different animal. It just has a different period. All the other ones have periods of 2 pi. Sine, cosine, secant, cosecant. So lock it in. It's a memorization factor. There is no I don't get it's on this. You just do it. And then what you got to realize for tan, since the period is pi over b, I'm going to put that up here. This distance is whatever pi over b is. Trying to write it real nice. Then this asymptote right here, because that's what happens with tangent, this is half the period, because I got to go half the period to the right and half the period to the left to draw the initial asymptotes. So this is negative half of the period. And I'll write that just because we're on the other side of the y-axis. So what is this really in terms of pi over b? Whatever pi over b is, this x value will be half of what pi over b is. And this x value will be negative half of what pi over b is. So you just got to take half the period, whatever it is, and those are your first critical values, and there are asymptotes for tangent. Why? Because. Ooh, is that a good effect? All right, sorry. Nobody smiled. I guess I'm annoying more so than trying to be comical. All right. And then what do you know about cotan? That one I'm not going to erase and rewrite. Cotans you're going to find is easier, I think. I always find cotan easier because I'm like, all right, you know what? I remember cotan of 0 is undefined. So it starts with the y-axis being the asymptote, and whatever the period is, that's the next asymptote. It's perfect. And then all I have to do is cut the period up into fourths to get these critical values. Oh, I didn't finish tan. My bad, dogs are rough. A and negative A. Those are just your stretches and shrinks. I'm sorry, A, and then I put that negative A in a bad spot because that's where I got to put my dot. So I'll put negative A over here. And then tangent increases. Why? Because the parent function, that's what happens. Right? So the babies will have the same thing, unless, of course, it's flipped over the x-axis or the y-axis. One or both could happen. And then cotan decreases. And then that's where A and negative A are, those little quarter values. So all these things have to be marked, and all the x-axis values need to be marked. We didn't break that. All right, and then this is what I did with the other hours, but I'm not. And actually, you should be happy because then you'll get out of here earlier. Just looking at something here. Oh, I do need to do something here too, so I'll give you a second to do something. I needed to save the attendance here. Good. All right, so we're not going to do breakout rooms, which will essentially get you out of here earlier. So I'm sure you'll rejoice with that. Then I can go to get my lunch earlier. Oh, I shouldn't have put that on the video. And oh, okay? Is John back? Yeah. I don't know. Okay. All right. So my first trick question. Ooh, I gave it away. Could you humor me in the chat? My 6 hour is actually the worst in the chat. I get the least amount of people that do anything in that class. Can you be better than them? In 5 seconds, what's the amplitude for this function? 5, 4, 3, 2, 1, go. Ooh, 2, 2, none, 2, none. Ooh, 2. Who's right? In a matching scenario, if I ask you what's the amplitude, the correct answer is none. Okay, good. All right, it is none, but the A value being 2, it's just our quarter values, the stretch or the shrink. So it's a mean question. I presented that to you already. Jerky, and I think we do ask it a couple times. Remember, sine and cosine have an amplitude because there's a high and a low. That's what that means. Secant and cosecant and tangent and cotangent go off to infinity and negative infinity. So no amplitude, but A is equal to 2. I know that's confusing, right? And then here's the other thing. When I had people break out in the rooms, both in 5th and 6th, they would put 2 pi over 3 is the period. And they're wrong, right? It's pi over 3 because the parent function for tangent is pi. So the babies are compared to that. All right, now what do I do with tangent? Okay, so I just said tangent is this. You got to remember, and this is why tangent's a pain. But whatever the period is, I cut that in half, and that's where the asymptotes are. So, and again, I know you think I'm a jerk when I say this, but it is frustrating. How many people cannot mentally picture what half of pi over 3 is? Ugh, it's a frustration factor for this teacher. The grade school stuff that is actually killing people in cat. Nothing more. So that's pi over 6. And because of the parents, so shall the child have the asymptotes at those halfway points. Because this is a distance of pi over 3. That's what you need to understand. So we still have a period of pi over 3, but just because of how tangent works, that's what you do with the asymptotes. Then the next thing, again, if you're writing these wrong, I am marking you wrong because you can simply just write this in 2 seconds. What is half of pi over 6? And then I finally see that all I have to do is multiply the denominator by 2. When I was working with 5th and 6th hour net rooms, they still had 3 seniors together, not able to come up with pi over 12. Okay, it is rough. If there's one thing my cat students walk out of here is knowing how to do a darn fraction. And then there it is. There's 1. What if I had to do 2 periods? Well, this is what I would do. 1 pi over 12. 2 pi over 12. Is that 2 pi over 12? Yes, it is. 3 pi over 12. What's that? Pi over 4. 4 pi over 12. Pi over 12 is the quarter value for the period. So to get the next critical values, I just keep having to add pi over 12. By the way, 4 pi over 12 is pi over 3. 5 pi over 12 is nice. I don't have to do anything. And then 6 pi over 12. Just writing them down took me 1 second. Then I can reduce. Okay, now notice how many more values I put. 4. So I asked one group 6th hour. Okay, so we just did that. Where's the next asymptote? And they're like, I go, now look, but we have 4 values here. So now I just gave you 4 more of the next ones. So I gave you the next asymptote by going those 4 spaces. Because then these are the next critical 3, the -2, the 0, and the 2. So then it all fits, and that makes sense. So these I'll definitely do 2 periods worth, and you'll have to do that mathematical fractional work. Any questions? Everyone all right? Yes, Mr. Thamulith. Then I'm going to do this one, and I change it to a cotan. I don't know why this old ancient worksheet, I just did I didn't do cotan, so change it now. Oh, and then my fifth hour, gosh, I had to apologize to them. I don't think I think I ignored the negative when I was talking about this. And then I screwed up one of the next examples. I know for a fact I did. Sorry, fifth hour. I think I got discombobulated when our breakout rooms did not go so well. That's kind of my fault. Period is pi over 2. Pi again, because cotan and tan. And then A is not amplitude, but negative 0.5. You'd say none if you're asked what the amplitude is. But I do want to put 0.5 and negative 0.5 here. And I'm going to make this real short. I'm going to do 2 periods, but I'm not really. Doing 2 periods of this is really easy. Okay, how does cotan start? Here's the parents. Okay, so the parent, as long as it's not shifted right or left, the cotan of 0 is undefined. So then the next asymptote is the period. So cotan, this is why you're going to love it. I could just go right to here and put the period. And then I could go ahead and do my fraction work. I'm not writing this off to the side. What's half of pi over 2? Pi over 4. What's half of pi over 4? Pi over 8. I'm trying to think where I want to put this. I want to put this up here. And there we go again. 1 pi over 8. 2 pi over 8. Yes, that's pi over 4. 3 pi over 8. 4 pi over 8? Is this 4 pi over 8? And the answer is yes. So since that's 4 pi over 8, that little generation I just did there, generating the numbers, is solid. And then that's where the next asymptote is. Oh, I didn't draw the first asymptote. Now, cotan is supposed to be like this. Supposed to be decreasing. Parents, decreasing. Okay, that is why I just said that from our extrapolation that we did, which we actually did with sine and cosine. Didn't have to do that with secant and cosecant because we knew what sine and cosine were, and they're just the flip of those. But anyway, flipping this over the x-axis makes it look like tan. You will see that tan and cotan are almost identical pictures, except where the asymptotes are, and one's flipped compared to the other. All right, that's why I said I was going to be lazy about a second period. All I have to do is cut and paste the x-axis values over here as negatives and then draw another curve, right? Pretty simple. Don't think we need to do that in the notes after what we've been through here with the others. That's why we love cotan. Cotan's really, really, really nice. You know what? I think formally, since we have shortened our time as far as what, you going in rooms, I'm going to have you look at these two. Ay, ay, ay. And this is from a picture. Can I get an equation? This is rough. So let's really focus on this one first, and I'll do 29. And then I formally have this in a video. Unfortunately, fifth and sixth hour will be short on that. So, oh, by the way, when we come back Monday, Mrs. W, I don't want to say her name on the internet, then I'll get sued, made a mirrored worksheet. We met Wednesday. I'm like, oh, really? Okay. And that's good. So I'm going to use it too. And that's what we're going to, come together and work on in school. And then I'm going to give you another worksheet, and that's what you can take home with you. But the mirrored one, there should be no complaining about like what's going to be on the test. So we're nice enough to do that. And I was like, yeah, I'm fine. Let's do it. So important day to be here, and then really use your time wisely, and that we can really clean up a lot of stuff. Okay, so this is tough, and it looks just like those other, cosine ones, same little stuff there. But notice that says pi over 4. So then my next question is equidistantly, what's that? And I don't want to worry about the chat. Everyone should know right away that that's half the distance. So everyone should know that this is pi over 8 right here. So this would be negative pi over 8. So then my next question is what is this period? What is that distance from there to there? I guess I want to ask in the chat. We should figure out that distance is pi over 8 plus another pi over 8, which is 2 pi over 8. So the period is pi over 4. That is one unique. Now, wait a minute. What is this? Is this a tangent or a cotangent? And the answer to that question is yes, because it could be a cotangent shifted right or left, but you don't know how to do that yet. Let's not think about shifting. Let's say unshifted. If we're talking about unshifted, this graph has 0, 0 as a point. Which of these two parent functions have 0, 0 as a point? Think to yourself, is it tangent or cotangent? 5, 4, don't have to put it in the chat. 3, 2, 1. It's this one. All right, but then what's wrong with that picture? So I'm seeing a tan here because tan is the one where the asymptotes are split compared to the y-axis, but it's upside down. Now, one other tough thing about this is the A value. If you look real close, this is marked as 2 up here. And then when I look at this about this quarter value, it does look like it's just 1 and -1 for those critical values. So my A value is 1. So putting that all together, remember period is pi over B. Oh my gosh, that's easy. What does B have to equal? I would go to the chat, but you know what? We'll leave you alone on a Friday. B is 4. So this equation is y equals flipped tangent graph. A is 1, fine, write 1 there. 4x. That's how you reverse analyze this. All right. And then this one we can do again. Probably a little tricky. Actually, this one's silliness. Okay, because I can see pi over 2 here. I should rather do this one than this one. This is pi over 2, so this must be negative pi over 2. That means this period is pi. That's the period of the parent function. That means b has to equal 1. Should ask in the chat, what do you see here, a cotan or a tan? Again, we're crossing 0, 0. And it's going in an increasing direction, so it's a tan. And then this says 4, so this is 2, so this is 1. This is the parent function, y equals tan of x, because b is 1 and a is 1. Y equals 1 tan 1x. Emily, are you okay? You're making a face of pain. Is it math? Okay. All right. And then you know what? Just for giggles, because I'm having fun. I don't know about you guys. I should put in the chat. Does that look like a tan or a cotan? Because everyone should know that answer. Put in the chat in 5 seconds. 5, 4, 3. Tan or cotan? 2, 1, 0. Oh no. I love how people are. I'll wait until other people put the answer. Sorry, was it Jeremy? Sorry about that. Did you change? Good, Jeremy changed. It's a tan again because it's 0, 0 is a point. It doesn't start with an asymptote, so all 3 of these are tans. Hey, I got a question. What's the period? Let's do that. Let's do the chat. What's the period in 5? Think about it. By the way, if you can't see this, this is pi. Delicious. And this is negative pi. What's the period? 5, 4, 3, 2, 1, go. Nice. Yeah, this distance is 2 pi as more people are rolling in. And then I have one more question. Remember, this is a quarter value. What's A in 5 seconds? 5, 4, 3, 2, 1. Don't say none. 0. Oh, it's not. There's no pi in it. It's not 1. We got to look at that picture a little closely. Nice, Adriana, Veronica, and then anyone else that wants to copy your answer now. Not that one more person, but 2. I got it. All right, because look, this hits 2 up here at the quarter value. All right, so really being specific, I'm looking at that picture. Now, how do you get a period of 2 pi? Remember, period is pi over b. So I could change this to b equals pi over period. So what's pi over 2 pi? 1/2. Then we'll see how that actually works when we type that in. So it's y equals 2, because it is quarter value comma 2, tan 1/2 x. And then you can see if I plugged in pi over 1/2, I would get 2 pi as a period. So good stuff there. The time took too long in my other classes when we were in the breakout rooms. We didn't get to do that. Oh, and then I have 2 more examples. Now you want to get nuts? Let's get nuts. Okay, so I put the little parents up there again, just to remind you. Looks crappy there. So one more time, remember, tangent, the period is cut in half for the asymptotes. Here's the y-axis. Whereas cotangent, the period is the next asymptote. Cotangent increases. I'm sorry, tangent increases. I think I said that wrong. Cotangent decreases unless we have a flip situation. I don't think I did that, so I got to do something with the... Oh, I did. Darn it. Oh, I got 2 saves. And there is no I don't get it. This is memorization, just like memorizing sine is 2 bowls. Cosine is the cosine kid. To graph cosecant, you flip sine. Watch this. Phew. And then for the cosine kid, I'd have to do a flip, somehow like contort my body to do secant. I can't do that one. But it's very similar to what sine and cosine are. These are all memorization factors. There isn't I don't get it. You do your homework and you keep doing it, and you keep coming in at 2 to 3, which I think I've said all year long since August that I've been available. Oh, darn it. Son of a nutcracker. Hopefully you didn't see that off to the right. Okay, so now we're getting nuts here. We're getting crazy. We're going to go and do everything that possibly could happen to a cotan or a tan. Hide this. Hide that. Okay, so do understand this also could be in a matching section where you don't have to graph. And you'd have a selections to the right, like with possible answers. So the first thing they would ask you is, what's the amplitude? Not going to ask you that again because I already tricked you. Hopefully everyone knows that in the matching, you should put none. There is no amplitude for cotan or tan because they go off to infinity. There is no upper and lower limit for the range. That's what amplitude really means. There is an A value of 3, but it's not amplitude. It's jerky, I know. Hey, be up to the test, be up to the trick. Get that little file in your brain, like a separate file in a secret spot. That's what learning is. Now, I bet you could get the period because you see this 2 value here. So many of you, if you put 2 pi over, you're missed the whole point of all these notes. All right. Again, another separate file. You got to keep a cotan tan file off to the side. Okay, period's pi for that. So I see that B value is 2. But the phase shift, we should know at this point that that is not 5 pi over 4. Okay, so that's what I had over here, and hopefully you didn't see it before I erased it. Because I want you to think, and again, it's fractions. Here comes the fraction jerk again. When I pull a 2 out of this, how does that affect 4? And I always get 2 different answers. It's either 2 in the bottom or 8 is what I get from people. And all I could say at this point, after doing this so many times, it's 8. Because if I throw 2 back in, 2 crosses off with 8 and becomes a 4. Cross cancel. Cross cancel. So now we got 5 pi over 8 here. Now I really want you to listen to me here. Really want you to listen. It is 5 pi over 8. And I apologize, fifth hour, if anyone watched. I did say 5 pi over 8 to the right, but I think I shifted left on accident in your notes this morning. No one said a word. Everyone just let it go, let it go, let it go. If you get the vertical shift wrong, this is like an easy point, man. So, okay, tricky on this one. We shouldn't miss this one. We should never miss this one. And then a little tricky on pulling out the 2. And we do have questions where you do have to factor out before you look at that phase shift. So really giving you the information here about what you're going to be having to do. And then I'm going to ask for an asymptote possibly in the matching section. And I'll show you after I do this question how you could find that without really having a graph. Okay, before I do the phase shift work, it's the same. What we're going to do is we're going to take our period, we're going to, and it's a cotan, and this is why I'm going to do this. I am going to go 0 to pi over 2, and you need to understand that that's where the asymptotes are. They are here. For cotan, it starts with an asymptote and ends with an asymptote. And then after we shift it, that's where the asymptotes are. So I do want you to know that. Because when we have a tan graph that we have to shift right and left, I'm going to do something a little different. Okay, but here's what we need to understand. And I got some head shakes in 5th and 6th hour on this, like thumbs up. You can go ahead and add 5 pi over 8 and you'd be fine. But 5 pi over 8 is an awfully large move right. As a matter of fact, pi over 8, wrong. That's a short circuit, Mr. Samuelis's brain, is 4 pi over 8 plus pi over 8. Why would he do that? Because your book is obsessed with this. I don't know why your book is obsessed with this. This is why I used for my notes this generator, and this generator did it. This generator gave me a phase shift that is larger than the period, right? Isn't 4 pi over 8 pi over 2? So really what it did is it took this graph and shifted it a period and then pi over 8. But then the graph over here would do the same thing. So really this is a meaningless shift here. I could get rid of that one full period part of the shift and just deal with the pi over 8 shift. How many people understand what I'm saying there? Shake your head. As a matter of fact, what I can't stand about our book, they give you a phase shift sometimes that is equal to the period. And now let's understand that. I take this graph and I shift it a period, but the one before that just shifts and lands right on top of the one I just shifted. So a phase shift that is equal to the period is absolutely meaningless. How many people understand that? So if you get a period of pi over 2 and the phase shift is pi over 2 left or right, it means nothing. All right. And the book does do that in the homework. So I hope you can understand that moving forward. So, long story short, I would not mark you wrong if you added 5 pi over 8, but here's what your graph would have to look like. You'd have to start your first graph like way away from the y-axis. And that's what you'd have to do, and it does get a little weird. So I'm not doing that. Oh, by the way, I didn't do my math work. Half of pi over 2 is pi over 4. I'm not explaining that anymore. Half of pi, I'm on fractions strike right now. Seniors don't know how to deal with fractions, and it's on them. Okay, half of pi over 4 is pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. Also, it's because we already did this one. We already had a pi over 2 broken down 4 times in the notes today. And then instead of moving 5 pi over 8, I'm going to get one of those periods out of there, that period part of the phase shift. Thanks, Ben. And then I could see a pattern develop. This is a really nice shift because pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8. Now I'm just adding pi over 8s. 4 pi over 8, that is 4 pi over 8. 5 pi over 8, and there's my one cotan. Remember what we said about right-left shifts? On the test, no lie, if we have a right-left shift, I'm only asking for one period. So I'll tell you what my answer looks like. And then if you did a 5 pi over 8 shift, I'll tell you what your answer should look like. So pi over 8 shift, there, that's pi over 8. That's my first critical value. Pi over 4, 3 pi over 8. Then when you get good with this, I'll tell you how you could find an asymptote real simple without having a graph because of time. Okay, So what did we say about cotan? Cotan starts and ends with an asymptote. So that's where the asymptote starts. It's shifted to the right. Another thing I screwed up in fifth hour, but then I caught it, is we didn't do our up-down shift. Okay, now 3 to -3, but move up 1. So now it's 4 is one of my critical values. 1 is, and then -3 moves up to -2. So all you want to do is mark those as numbers on the axis so you pay attention. Cotan's not flipped. So let's look at the parent one more time. Cotan decreases. So between the asymptotes, we have a decreasing behavior. So this is the high point, not the high point, the higher A. This is the 0, but now it's moved up 1. And then this is -2, which I crushed pi over 2 with my graph. Now, if you left 5 pi over 8 as your shift, then here's where your graph would have started, and you would have just done math to do these values. So if you shifted 5 pi over 8 to the right, you'd be fine, but you would have to be far away from the y-axis. And I really hope you understand that. So if you didn't understand the whole period, there's more than one period in the shifting, just go ahead and move 5 pi over 8 to the right, and you're fine. Okay, I only got one more. We got 21 minutes left in class. Oh, I can't wait. I'm having a Lockport lunch today, going to celebrating after this long week and a half. Oh, it's a rough week and a half. My math tours are driving me up a wall. Anyway, having pops if you care. Definitely a beef sandwich. Okay, amplitude equals none. If you mess that up on the test, it's on you at this point. There is an A value of 3, though. Period. Oh, no, I don't see anything. So it's pi over 1. Pi. Tangent. Phase shift. No fancy factoring. So phase shift is pi over 3 left. Now watch how bad this is compared to the period. But all it is fractions. So let's not make a big deal out of it. Vertical shift. Up to. And then finally, oh gosh, I didn't do that in the last one. Asymptote. Let's go back up to the asymptotes here. Okay, equation of an asymptote. Sorry, on this last one, you see them. It's x equals pi over 8. Or another one, if you shifted 5 pi over 8 to the right, then it's x equals 5 pi over 8. There's a couple of them. Okay. What are all of the asymptotes? That's a good question, Mr. Samuelus. Thanks, Daddy. All the asymptotes are a period away. So it's x equals one of them plus period times n. Okay, that's what's nice about tan and cotan. Remember, for secant and cosecant, because there's two graphs, there's an asymptote in between the period. So it's half the period, how far the asymptotes are away. Okay, so just remember that. So you could have done that without knowing cotan, the asymptote's x equals 0. Well, then my asymptote is x equals 0 plus the shift. And that's what the asymptote is. All right, and now we got a problem with tangent. I did something different with fifth hour, and it's okay, but I did kind of make it a little bit more challenging. Remember what happens with tangent. And what happens with tangent is when I get the period, the smartest thing to do with that period is split it in half and go negative and positive. All right, because that's where the asymptotes are. I didn't do this with fifth hour. It ended up being fine, but I'm going to do it better with you guys. So instead of doing 0 to pi, remember at 0, that's the 0 for tangent, 0 comma 0. I'm going to go ahead and get my asymptotes, which is half of the period, positive and negative. Then I want to mark those as that's where my asymptotes are. That's the rule for the parent. So that's the rule for the baby. And then what I'm going to do is, okay, right in between that is 0. That's the 0 for tangent, 0 comma 0. And then what's in between here? Half of pi over 2. So whatever the period is, you cut it in half. And then this value is cut it in half again. And then I'm going to move pi over 3 to the left, which is subtract. And then all this is not calculus. I know you get mad when I say this. Well, I'm mad about how bad fractions have been over the years and how students say CAT is so tough when really it's just these little things that are grade school related. And really want to get you to invest in that this is something we just need to get better with. So those dang fractions buttons on your calculator really is -5 pi over 6. They never should have invented that. Just like I'd like to, you know what? I'm going to put it on. Go ahead, tape this. Go ahead, send this to somebody. Whoever created photo math, I'd like to walk into that office and punch them right in the face because you know what they've just done to this. This is what's going on with my math tours. They're playing games that they don't. I don't know how to do anything. Although online, how many people photo mathed on their tests? And now when we came in, you had to write the answers on a piece of paper. They can't do it because they don't have their phone to take a picture and copy the answer. Roar! Hey, how's everyone doing today? Good? I'm fine. All right, so -3 plus -4 is -7 pi over 12. Did he say he was going to punch someone in the face? I'm not going to do it, but they make me angry. Creating a society of cheaters that won't be able to function. 3 pi minus 4 pi is -pi over 12. And then the last one, not changing colors anymore, taking too much time. 3 pi minus 2 pi is 1 pi over 6. Okay, so notice none of those are 0. All right, so the y-axis gets skipped as a value that's critical. All right, and then boom. This is going to be tough. So just, I might, if I were you, it's okay. I got negative pi over 12 and positive. I might start with that. So negative pi over 12 would be here, just because I want to get my spacing. And then pi over 6 is bigger. It's actually double. Pi over 6 is twice as big as pi over 12 that way. Because the other time I started here and I kind of got in a spatial issue of getting the next marks here. -7 pi over 12 and -5 pi over 6. Okay, then remember why we did this. Remember why we took the period and cut it in half, because now it's easy for me to graph this. Now I got where my asymptotes are, right? And I didn't do that with my other hour. I went 0 to pi, and then 0 to pi, and then I had to start here, and it was like, oh, sorry guys, that's where the 0 starts, and I had only half of a tangent curve, so it was still right, it just didn't quite like it. Oh, and then I almost forgot, and we're almost done. 3 to -3, but up 2. So don't forget about that. And I did forget about that in my first example, and then we went back and corrected it. So it's all good. 2, and then 3, -3 up 2 is -1. So you want to mark that on the axis. Just mark those 3 numbers. That's a 5. So that you know. And it's not minus, this is plus. If that was minus, I'd just make it upside down. But it's not, and tangent increases. So I have to put a point right here on 7 pi over 12. This is the 0, but now at 2. And don't hit the y-axis. It's at negative pi over 12. So kind of bad that I hit my values here, but we're all good. All right, and then asymptotes. Here's how you can get the asymptotes without graphing. Oh, it's tough though. Period's pi. Half of pi is pi over 2. That's where my asymptote is. Oh, but then I have to subtract pi over 3. So my first asymptote is pi over 2, half the period, and then pi over 3 shift. That's how you can find an asymptote without graphing, just understanding how the asymptotes work. And then how far away are all the asymptotes? Pi n. By the way, pi over 3 minus, or pi over 2 minus pi over 3 is that 5 pi over 6 value. I'm sorry, pi over 6 value. Or it could be negative 5 pi over 6 in here. One or the other. That is the equation of an asymptote or of all of them. Okay? All right, now we're done. At least you're 12 minutes early. If anyone wanted to stick around and ask a question, go for it. Sorry for my explosion on the photo math people, but it's correct. It's been abused into a cheating component and not a helping component. All right, we'll see you. I'm done with my little diatribe. By the way, diatribe is a negative rant. Little English for the students today. Is he still talking? Oh, I gotta end my video.